let's see here. We have 1 over x minus 1 is 1 over x minus 1 minus 1. Okay? So common denominator that has to be multiplied out would be the x times the x minus 1. Okay? When you multiply everything by the x minus 1, remember that goes to each piece. So a lot of times what we would say is the first fraction has the x minus 1, it needs the x. Second fraction has them both, so it's just the numerator. And the last fraction needs them both. Now remember, this is the trick. There's a negative there. And x times the x minus 1 was x squared minus x. Okay? You have to distribute that negative. That's where most of you guys make mistakes. Whenever you have minus something in the distributive property, you forget about that secondary sign. Okay? So you get x is 1 minus x squared plus x. Okay? Bring everything to the other side. So we have x squared minus 1 is 0, so x is plus or minus 1, which, let's see, positive 1 does not work, but negative 1 does work. So positive 1 is your only solution. I'm sorry, negative 1 is going to be your only solution for that one. What else? Yes, sir. Oh, sorry.
For the thing 1, how do you know the take out the
What? I'm sorry.
take out the
Oh, for that first part.
Yeah.
Well, remember, whenever this is your first rule for setting up these things, you get the common denominators. You always want to factor anything you can. Okay, that's why I factored that first as I was writing it down. Okay? Just like whenever we had a trinomial, we would factor it right away, and then just go from there. What else we got? Yes, sir. 18. I believe. I think it was. If not, I can get a copy of it. 18, so let's see, we have x, what times what's 24 to get to 5, so it would be positive 8, negative 3. 40 to get you 3 is positive 8, negative 5. 20 to negative 1, minus 5, plus 4. And then 4x plus 4. Again, all I'm doing is I'm factoring as soon as I'm writing it down, and I just start. And you're done. Which one? 6? So in this case here, to get the common denominator, guys, when you do the common denominator, you're just putting the two parts together. So you know it's going to have to equal x minus 6, x plus 1, and the denominator. First fraction needs the x plus 1, so it'll be 6 times the quantity x plus 1. Second one needs the x minus 6. And remember, all we have to do is always multiply out your numerators, combine like terms in the numerator, and then you can leave the denominator. So you get 6x plus 6, 2x squared minus 12x. So if I rewrite that, I get 2x squared minus 6x plus 6 over the it depends on what the, I don't think they, I mean, that's all I would have you do, because I would just have you multiply it out. Obviously, I'm sitting here thinking I'd pull out a 2 and write it as x squared minus 3x plus 3, but then that doesn't get me anywhere anyway because you can't factor it. So whenever you multiply out, you just want to always take a quick double check, see if anything can be factored out. Sometimes it might be hiding in there. Especially with the adding and subtracting ones. Okay. Just always take a quick look. Yes, sir?
14.
14. So let's see, we have 16 over 9. Okay. Excuse me. All right, so as we go through this one, this case, treat it like you have two addition problems. That you have to get two separate common denominators. So just do them one at a time. It'll be a 9 x minus 1. So it'll be 16 times x minus 1 plus 4 times 9. So that gives me 16x minus 16 plus 36. Okay. And 36 and then negative 16 got me the 20. I just skipped right down that intermediary step. Okay. At that point, I'm probably starting to think, ooh, I could probably take out a 4 if I needed to. Depends on what happens later on with any of the other things I can simplify. Here, again, we have 4 and an x minus 1. So that first fraction needed the x minus 1. So what I'm going to do is rewrite it as the x squared minus x times the x minus 1, because that way I can FOIL that out easier. Okay. And then the other part is just going to be the 3 plus 12, basically. Okay. All right. So now we just have to FOIL that out. You get x cubed minus x squared minus x squared minus x. So let's see, that'd be x cubed minus 2x squared minus x plus 12 all over the 4 and the x minus 1. Whenever I have that 4 terms with a cubic, check and see if it's groupable. It's not going to get you anywhere at all in that one, so there's really not much we can do. So now we just have our last little bit of 16x plus 20 over 9x minus 1 times the 4x minus 1 over the x cubed 2x squared minus x plus 12. This one's just kind of boring because you really can't get much out of it except for the x minus 1s. And then, like I always say, multiply out your numerators because nothing else is going to simplify there. So it's at 64 and 80. And that would be fine, because there's nothing else you can do about it. It's just kind of gross.
That works.
There's no reason. Yeah, remember, you don't have to multiply out the denominators, just the numerators. It's one extra step you can screw up. On 5, so right off the bat, I'm simplifying the 3's. Okay, I simplify the 3's right away, and now all I like to do is multiply everything by the common denominator be the x plus 1. What's that? I mean, if you did it later, it would have still done the same thing. So this just basically turns into x over 1 minus the 6x plus 3 over x plus 1. Well, common denominator is x plus 1. Multiply the left by that, and you'll get x squared minus x minus 6x plus 3. Most people, again, will forget to distribute the negative to the positive 3 value, and that's where most people screw up. So your final answer would be x squared minus 7x minus 3 over x plus 1. And that numerator is not factorable. Did I write that as x? I'm sorry, that should have been a plus. I looked at this one, I'm sorry, that should have been a plus, this would have been 5. Sorry, I just realized that as I backed up. I think I looked at a minus, when I was looking at this one as I was multiplying out, the one above it had an x minus 1. I looked at that as I was writing that down, so that was my fault. Okay. Good fun. What else we got?
Number 26.
All right, so in this case here, this is one of the style of the graphing problems. That's the A, H, and K one. Okay. Yeah, go ahead. Just grab the. Oh, I lost my ruler. Our ruler's back here. That's that A, H, and K one, where your x-intercept. You don't really have that. You don't have the x-intercept values of taking the numerator like we have been. So this one here, we know that our vertical asymptote is going to be at 2, and x equals 2, just the 0 of the denominator. The k value is a 0, all right? So that's your 0, so your horizontal will be at 0. Our a value, excuse me, is 1. So now it's just a matter of, this is the one where you get to pick points, okay? Vertical asymptote at 2. Horizontal will be at 0, because the k value is 0. H is the 0 of the denominator. Think of it that way. This one's just because we usually wrote it as x minus h. Well, this case that x has a coefficient. It's still the 0 of the denominator. It always is. So here, I would pick 1 and 0, 3 and 4. Those would be my x values I would choose. If I throw 1 into that, I get 1 over negative 4, so negative 1/4. I throw a 0 in there, I get negative 1/8. 3, if I put 3 in there, I get 1/4. And then if I put 4 in there, I get 1/8. Convenient. Okay. So now it's just a matter of plotting those through. So at 1 is negative 1/4. And then we're at negative 8, so that means it's probably doing this. And then same idea here. It's just tough to plot when you have those really close like that. But labeling parts and go. Okay. Absolutely. It's okay if it's not perfect, because what you're telling me for ones like this, you're telling me my ordered pairs, and you're telling me where the asymptotes are. Okay. Your vertical asymptote is at 2. Your horizontal asymptote is at 0. Okay. So you're telling me those things. The graph doesn't have to be perfect, but you found the ordered pairs like they would be, and you got the asymptotes where they're supposed to be at, and that's what we're looking to be able to do. Okay. That style, and then that one. Yeah. I think from first day, there were ones that had the graph where you could do that, where you had like linear over linear. That's the only other style I'd ever asked you to make ordered pairs for. Which one? Sure. So 24, we have negative 4x plus 16, x cubed minus 6x squared plus 8x. So this will be in the style in which you'd have to just give me all of my asymptotes, x-intercepts, y-intercepts, things like that. I'm not going to have you find ordered pairs or something like this, just because it's a big, giant, awful, awful, awful thing. So first thing we do is get our x-intercept. Remember, your x-intercept is the 0 of the numerator. So just set the numerator equal to 0. We get x is 4. Okay, so there's your x-intercept. Your vertical asymptotes are the zeros of the denominator, so we have to factor that. So that gives me zeros at 0, 4, and 2, because that factor term would be x minus 4, x minus 2. So 0, 4, 2. So as of now, the only thing you can plot for me, 0, 4, 2. Okay. I know it says it's an x-intercept here, but that's technically what you'll learn next year as a whole. No big deal. It's what we were talking about earlier. It's because it can get factored itself out if you simplify it. No big deal. Okay. Does this one have a horizontal asymptote?
No.
It does not, because the degree in the numerator is less than the degree in the denominator. And that's really all you can do for that. What's that? Yeah, real fast, what we had our x-intercept, our y-intercept, I can't do the y-intercept because if I throw 0 in,
It's just going to be undefined.
It's going to be undefined, so that's why we have no y-intercept. Okay, yes, sir?
I don't understand why.
So what happens here is this numerator, you take out the 4, you get x minus 4. The denominator becomes x minus 4, x minus 2. These guys would simplify out. Even though they simplify out, it becomes a hole in the graph. Okay? It's a pre-calc thing. It's just one of those weird things. I gotta save them something for you guys to learn. But try to. So, what else we got? What about the other stuff from the day before? How are we doing those things? Because those shouldn't have been that bad. Those are just straight graphs, and those. That way you can still, again, you're just plotting, make sure you find all the right parts and stuff. Let me grab that one.
I already saw
Sorry about that. Which number was it? Ladies and gentlemen, come on. that one?
Yes.
Okay. Gotta make sure I have the right number 8 here. Okay. So again, as we go through these things, remember, first thing you're gonna figure out is the 0 of your numerators is going to be your x-intercepts. Means I gotta factor that one. As you factor that one, you're gonna get x squared plus 2x minus 3. What times what's negative 3? Add together, you get positive 2. 3 and negative 1. So your x-intercepts, all right, 0, negative 3, and 1. Okay. Your vertical asymptotes, we have to factor the denominator. So when I do that, I'm going to take out the negative x, and I'll get x squared plus x minus 6. The reason I take out that negative x, because it's even if that's negative, where's the 0 going to be still? It's still going to be at 0, isn't it? Okay. So that's just a little trick for that one. That way you can factor that x squared term without it being negative. And that'll get you, what, plus 3 and a minus 2. So we have vertical asymptotes at 0, negative 3, and 2. Okay. Again, it's very similar to the one we had earlier. Those x values would be able to factor themselves out, so you wind up with what are called holes in the graphs. Again, it's not a big deal for us. We're just labeling where things occur. You guys don't have to worry about this thing called holes. It's the end of the world. And then the last thing you can do here is we have to figure out the horizontal asymptote. The horizontal asymptote here is going to be at negative 1 because the degrees of the numerator and the denominator are the same. So that's when you take the leading term coefficients. 1 over negative 1 is negative 1. So your horizontal is at y equals negative 1. This one does not have the technical y-intercept because if you throw in x equals 0, you'd be dividing by 0, and then that thing's negative. It's not allowed. Bad things, man. Bad things. Yes.
Black.
So 6, you've got, get your numerators. Ladies and gentlemen, come on. Get your numerator, your x-intercepts by factoring. So x minus 3, x plus 2. So that 3 and negative 2 are your x-intercepts. Your vertical asymptote will be at negative 2. Again, just means there's a hole in it. Okay. And then this one has a degree in the numerator that is 1 more than the degree of the denominator, which... Oh, that right? Yeah, sorry. Yep. Hi, good morning. Now it is. All right. So now it's just a matter of getting this one's going to have the slant. So when you have the slant asymptote, remember, take your numerator, x squared minus x minus 6. What do you multiply 3 by to turn it into a 1? 1/3. Very good. So you multiply it by 1/3 x. That gives you x squared minus 2x. Subtract, excuse me, to get x again. And this drop down doesn't matter. What's going to be the last little bit then? It's another positive 1/3. So your slant asymptote would occur at 1/3 x plus 1/3. Well, I don't know, maybe like this. Again, I'm not going to have you guys find ordered pairs for something like that because it's just a pain. But you could tell me where the y-intercept is. Where's the y-intercept for this one?
-1, or no, +1.
Yeah, your y-intercept. Your y-intercept is at 1. Okay. So, just with the y-intercept and that x-intercept on the left-hand side, my guess is it probably does something like this. Which means it has to mirror the other way around. But again, you'd have to have a calculator to do all those ordered pairs, and I'm not going to give you ordered pairs. Okay. There's a hole in the bucket. Why is that? What else we got? Excuse me.
With your beach, I use the
So I'm making you remember 3 things. Oh, the
One of the 3 things that's
all right there. You're working with your asymptotes or something? Yes, ma'am. 9? What the?
do not ever do that again.
So let's see. X-intercept at -2. And then in the denominator, first thing we do is factor out the -4. Factor out the -4, and then that gives me x minus 2, x plus 1. So vertical asymptotes at x equals 2 and -1. The degree of the numerator is 1 less than the degree of the denominator, so that means we have our horizontal asymptote is at 0, I believe. Is that right? Yeah. Is it at 0? I think. Is that what for some reason I'm drawing a blank.
I don't know. I thought of
One. Oh, I'm sorry. I'm thinking. Yeah, this one doesn't have the horizontal. On this one, for degrees less than.
Yeah, this is number 9.
Okay, I was thinking backwards, and I'm sorry. Jeez. And then the last thing you could do on this one is you could get your y-intercept when x equals 0. Your y-intercept would be at 1/4. So honestly, the only things you could plot, x-intercept at -2, asymptote, asymptotes. I mean, it's really not much you can do on this one. Okay. I'm not going to have you find order. Excuse me. Good times.
So does that mean if the x-intercept is -2 and the horizontal asymptote is on 0, is that a hole?
Again, that's something I'm not really worried too much about the whole stuff.
You have a hole. Yeah, you're not telling me that
Because what happens is the factor of the term. I'm trying to think if there's another one. On 10, don't forget you got to get a slant asymptote on number 10. When you do the slant asymptote for number 10, you got to put a placeholder in. Hopefully you remembered that.
Oh, yeah.
Then you just had to do some fraction stuff. The one that shouldn't have been so bad. What was the other one that was on here?
That's.
I think there's any other weird ones I did. What else you got? Again, guys, x-intercepts at plus minus 1, vertical asymptote at -2. And then, since the degree in the top is 1 more than the degree in the bottom, we have no horizontal asymptote, but in this case we have the slant. So you do your long division. X squared, 0x minus 1. This is very similar to the one we did a little while ago, about when you multiply 3 by it, turn it into a 1. This is where you got your 1/3 x again. Multiply that through, we get x squared plus 2x. And then when you multiply 3 by it, turn it into a -2. -2/3. And then that's how you get it back.
Yeah.
Really, the only other thing you can get out of this thing is your y-intercept. Your y-intercept in this case would be at -1/6.
Yeah. Okay, you start at 1/3.
No. Slope intercept form is mx plus b. You always start at b. You start at -2/3 and go up 1 over 3. Sorry, stretch. What else we got? Go through 7. You have factor the numerator plus. Factor the numerator, you get what? -4 plus 3. So your x-intercepts, vertical asymptotes, at plus or minus 2. Your y-intercept is at 3. And then your horizontal asymptote is at y equals 1. If you had to rough sketch just that, without ordered pairs, it's really simple. Intercepts at -3, positive 4. Asymptotes at 2, -2. Y-intercept at 3, horizontal asymptotic. From there, that's probably all you'd have to be able to do. I bet you that if you threw that in there, I bet you it looks like this. Probably just that. And I bet you there's something in the middle there. Is my guess. But I could be wrong. Because I'm never wrong. Because we have the big book of answers. Yeah. I don't know if it's prime or not, but I also let you use whatever you want. No, I'm saying is that I've got the big book of answers in the cabinet. You can look at it. Take a picture of it. You're not disseminating it to others. You're using it for personal use. That's what Slater's for. Done. They do?
Yeah, they play
That'd be pretty funny if I wore like a Slater like t-shirt. It just says Slater on it? That's awesome. I like it.
I didn't know.
What else you got? Anything good? Nice. Good fun. I started rewalking my shower. Yeah, okay.
What did you like?